Okay, as promised, a little kinematics review, because for some of you, you have not done kinematics in a year. So the question is, do you remember the equations? There were really 4 equations. Some people would say there were 5. The first 2 are from grade 11. The first one is VAV is equal to, do you remember? Delta D over delta T. Maybe if we're doing the review for the kinematics, we should remember that there is displacement as I write distance, and distance as I write displacement. So my hand and my mouth are not in sync. One's a vector and one's a scalar. Do you remember which one's which? I'll let you pause and think for a second. Distance is the scalar. If you remember from grade 11, distance is how far an object has traveled, how far something is from one point to another. It's you to measure the length of the path, whereas displacement is how far you are from the end point from where you began and the direction. It's a vector. So if I were to walk around the room, so here's my room and I'm standing here, I walk this way and I walk this way, the distance is how far I've actually traveled. The displacement would be the straight line distance, okay, or straight line displacement, okay, the vector. Okay, that's connected then to speed and velocity, because speed is the distance over time, and it's a scalar, whereas the velocity is the displacement over time. And if you remember from last year, as soon as an object changes direction, the velocity kind of becomes meaningless, right? So if you're a runner and you're running in a straight line and you measure your distance and your displacement are really the same, just the displacement would have a direction divided by the time, and you get your speed and your velocity. But if you run in one direction, then you turn around and you run back, now your distance is twice whatever this length is, divided by the time gives you the speed, but your displacement is 0. You're like, wow, you're not much of an athlete. Like your velocity is 0 if your displacement is 0. So in sports, it's usually the speed that we'd be more worried about. Think of a soccer field or a football field or an ice hockey rink, right? During the game, you're all over the place. Your distance will be huge, but your displacement might end up being 1 meter. Your speed would be huge. Your velocity would be not realistic of what was really going on. The same with swimming. If you're in a swimming pool and you swim down and back, well, your velocity is 0. Like, you better keep training. You're not going very fast. Okay, and then the third one, so velocity is the vector, displacement is the vector. And then the third one was, if you remember, acceleration. How quickly your velocity changes with time. Acceleration is also a vector. Okay, how quickly your velocity changes with time. All right, and that's the third equation. And remember, there are 3 ways you can accelerate. You can speed up. You can, do you remember? You can slow down. And you can change direction. So if I'm walking around the room like I was up here, even if I'm going at exactly the same rate, when I've turned, I've accelerated because I've changed direction. And we'll get into that this year when we do uniform circular motion. The planets going around the sun, even though they're going at exactly the same speed, are actually accelerating because they're constantly changing direction. All right, so we come back over here then. So this is the average velocity is displacement over time. The average speed is distance over time. The second one is also from grade 10. It is A is equal to VF minus VI over delta T. So the acceleration is equal to the final velocity minus the initial velocity over time. I had said there's kind of 3. The other one is VAV is equal to, average anything is equal to the final plus the initial divided by 2. And so there are books and places that would take this and fill it in up here, okay? This one for me is common sense, so I don't tend to worry about it too much. All right, And then there are the two great ones from grade 11, which I'm hoping you still know off by heart. First one is delta D is equal to, can you say it? Say it loud so I can hear you. VI delta T plus 1/2 A delta T squared. And then the other one is VF squared is equal to VI squared plus 2A delta D. Remember, I want you to be able to say these two backwards while standing on your head and humming O Canada and Swahili at the same time. You should know them, just like delta D is equal to VI delta D plus 1/2 A delta T squared, VF squared equals to VI squared plus 2A delta D. You should know them off by heart. And these two, they've been in your brain for so long, you should know those two. Okay, so we're going to do a little review first with just one-step ones. So this sheet that I gave you in class, these first ones are one step. And if you were in class, I would time you and make you go. You should be able to do without any difficulties like the first 12. Now the very first one doesn't actually even use the equations, but the others do. They are pretty pathetic. The first 12 you should be able to do in about 15 minutes. How about, I would like you to go to maybe number 14, because then we get into two steps, and you are welcome to try them. These are not to be handed in. They are homework, and if we were in class, I would give you like 2 minutes to do one, we check the answer. 2 minutes to do the next one, we check the answer. And for some crazy reason, I copied this sheet without the answers, which is just ridiculous. But we'll hit the answers then when you come back, and then we'll find out which ones we need to do. Okay, so today then, that's the end of the videos. Today I would like you to work on the first 14, okay? And then your homework is to finish the math sheet. Okay, but if you think an hour in class, you would be able to get the first 14 done because you have, this is at the 7-minute mark, so there's been a video that's been 17 minutes. You have 43 minutes. You should be able to do the 14 in that time. Please write down the equation, rearrange it for the unknown, fill your numbers in with their units, and find the answer, okay? Remember those steps. That's what this review is for. And when I see you, we will start the two-part ones. We'll have finished the math sheet, we'll have finished the easy ones, and we'll start the two-part ones. Okay? Sound like a plan? Very good. Take care.